Where we weren't 10 years ago was as far with AI from an enablement and intelligence perspective. We didn't have the models we have today. We didn't have ChatGPT was not a household name. We've come a long way from what's actually aligned with how people want to use these devices. And I think what I will say is we have a much more fluid interface as we're dialoguing now. That's where we, I think, are on the cusp of what we can bring to these smart home devices by way of conversational interfaces. You have a GUI, graphical user interface, you have voice AI. I think that's what's coming to the edge. But why it should be at the edge is because privacy, security, and real-time interaction.
A lot of challenges. It's definitely not a trivial task to do a lot of these AI things on the edge, but I think we're getting there. There's more development on that side to enable these kind of smart refrigerators. It's getting there.
When the smart kettle was invented, right? It's so smart you still got to fill it up yourself. And cameras in fridges, great, but you still have to go and get that milk, right? So I think your point around actually what the consumers want, as opposed to what we believe that they want, is quite a separate thing.
The embodiment of these real solutions comes with the new term that's been thrown out there called physical AI. We're not fully there yet. We're on the cusp of, I think, a lot of great solutions, but the physical embodiment of these solutions is still in the human being. And so I think you can make your life easier, you can add more intelligence, add more data, but I think a really exciting era will be when you can actuate the solution and not just perceive it.
Welcome to The Edge of Tomorrow, the Edge AI debate, our spin-off series on the IoT podcast. It's brought to you in collaboration with our great friends from the Edge AI Foundation. We're bringing together some of the brightest minds in Edge AI and beyond for high-stakes discussions on the most pressing challenges, opportunities, and emerging trends shaping the future of AI at the edge. This isn't just another AI podcast. Every episode cuts to the core of technology we're building and the path we're on, offering diverse perspectives, hard-hitting analysis, and the kind of conversations that leave you questioning everything you thought you knew about Edge AI. In this episode, host Tom White is joined live from the NXP Smart Home Lab in Austin, Texas. Tom will speak to Davis Sawyer, AI Product Marketing Manager, and Anthony Huereca, Senior Embedded Systems Engineer at NXP, to discuss the strides NXP is making in Edge AI for smart homes and beyond, as well as the emergence of physical AI and if and how we can reach standardization in AI. Plus, we'll be also showcasing a tour of some of the solutions in the lab.
Gentlemen, thank you for joining me on the Edge of Tomorrow, the Edge AI debate. Genuinely, I don't think I've ever sat in a more cooler location to film a podcast.
Nice.
Here at the Smart Home Lab, NXP's Austin office. So just to introduce you two for our audiences at home, we have Davis Sawyer, AI Product Marketing Manager, and Anthony Huereca. Did I say it right?
Huereca.
Oh, Huereca. Kind of right. Senior Embedded Systems Engineer at NXP. Thank you so much for joining us on this debate today.
It's our pleasure.
Thank you.
All right, cool. So, as I say, we're sat here in NXP's Smart Home Lab. What a fantastic place and what a campus, right? Absolutely tremendous. Could you maybe give a little bit of introduction to what you do within the business? And Davis, maybe we can start with you.
Yeah, happy to. So relatively new to NXP. I've been here for just under a year, but not new to the AI tools and enablement space. So I'm tasked with how do we bring more value to our customers, our end users by way of software, tools, solutions on top of the chips. So obviously a silicon vendor in the AI space, a chip is not one and done. You need more than that to create a full solution. So I'm tasked with how do we provide more value to our customers with all of the above algorithms, models, and tools.
Nice. And Anthony, how about yourself?
So I'm a systems engineer. I've been with NXP over 18 years now. I'm the systems engineering group. So my task and role is doing customer support, helping develop training and content. See my name a lot on the collateral that we develop for like labs on our AI/ML. And over that 18 years, I've worked on a variety of different embedded areas on microcontrollers, from RTOSes, BLE, wireless, now AI/ML.
18 years, that's we were saying that backstage, that's really quite an impressive tenure and a relatively new to the business yourself, David. So it's great to kind of hear your individual aspects on working in the business. So I guess, look, we're sat in a smart home lab, right? Everyone knows the stories around, a decade ago of smart fridges texting us our grocery list and telling us that we were out of milk, etc. I guess it's really befitting to know, where are we today in 2025 when it comes to smart home automation, the tools, the gizmos, everything that we were promised 10 years ago. Are we there, or have we still got some way to go?
I mean, I can break this. It's a good question. I think 10 years ago, we maybe knew it was possible, but we didn't know as much about what people wanted. What do people actually want to use? We're all consumers, we're all end users of these appliances. We have them in our homes, we have them in our hotels. I think where we weren't 10 years ago was as far with AI from an enablement and intelligence perspective. We didn't have the models we have today. We didn't have ChatGPT was not a household name. LLMs were not even in the diction. So I think from that perspective, we've come a long way from what's actually aligned with how people want to use these devices. And I think what I will say is we have a much more natural interface, a much more fluid interface as we're dialoguing now. That's where we, I think, are on the cusp of what we can bring to these smart home devices by way of conversational interfaces. You have a GUI, graphical user interface, you have voice AI. I think that's what's coming to the edge. But why it should be at the edge is because privacy, security, and real-time interaction. So I think the godsend that AI has been for these devices is that natural conversational interface, and we're fortunate to be able to take the upside of that by way of bringing it to the edge devices that we use every day.
Fantastic. Yeah. And Anthony, what's your view on it?
So I would agree with Davis. I think it's kind of almost trickling down to the embedded side. So you have these very large models that have been developing, or that customer users have been developing, and so now how do we get that into the embedded side? How do we shrink that down so it can fit in an embedded system, an applications processor, even a microcontroller? And there's still a lot of challenges. It's definitely not a trivial task to do a lot of these AI things on the edge, but I think we're getting there. There's more development on that side to enable these kind of smart refrigerators, as you were saying. So it's getting there.
It's funny, I was talking about this week. Obviously we're in Austin for the Edge AI Foundation event, and it's part of one of the reasons why we're here today. And I always laugh when the smart kettle was invented, right? It's so smart you still got to fill it up yourself. And cameras and fridges, great, but you still have to go and get that milk, right? So I think your point around actually what the consumers want as opposed to what we believe that they want is quite a separate thing, isn't it? Would you agree with that?
I definitely would. I think you have to test the waters a little bit. You need to try new stuff, take risks to understand what will stick. I think the embodiment of these real solutions comes with the new term that's been thrown out there called physical AI. So you have perception algorithms. You might have this ability to recognize things, but to actuate it, to go get that milk, as you say, still needs to be done by some physical entity. So I think as Anthony was saying, we're not fully there yet. We're on the cusp of, I think, a lot of great solutions, but the physical embodiment of these solutions is still in the human being. And so I think you can make your life easier, you can add more intelligence, add more data, but I think a really exciting era will be when you can actuate the solution and not just perceive it.
Yeah, it's a fantastic way of putting it. Yeah. So I guess for me, we're in 2025. If you're not doing something within AI, you are really being left behind, right? It's one of the biggest technology shifts I've ever seen. We talk about IoT, we talk about crypto, blockchain, NFTs, various different technology kind of drivers over the last five to 10 years, but AI really is huge. And I guess the question for me is, are we actually seeing AI currently today drive real automation, or are we just kind of improving some voice assistants, right? And is edge AI playing second fiddle to the cloud ultimately? What's your views on that?
Do you want to start?
Sure.
Big questions.
Buy me some time to think.
I think it's kind of two different categories a little bit at this point, because obviously you're not going to fit ChatGPT on an embedded system today. There's a lot of work on optimizing that being like a focal, specialized LLM, and that can fit on an embedded system. But I think ultimately the use cases are going to be kind of different, and what you want to do with an AI model. One thing I really enjoy in working in this field is that it's opened up new applications that weren't really possible before. AI, that's why I'm excited to work on AI, because there's things that we can now do on the embedded side and in the cloud that just weren't possible. And so I think we're still scratching the surface of what we could really do with AI, because before it was hard to, we could tackle these tasks that we didn't know how to do on a computer, or that were very difficult to do on a computer. I teach a lot of training classes on AI and on enablement and all that. And so one of the things I point out is, as a programmer, how would you recognize a person versus a dog in a camera? when you're analyzing that image. And if you're just writing C code to do that, that's going to be very difficult to recognize those kind of objects or make that differentiation. But now we have AI, and that can make those kind of complex situations possible for the first time. And so it's really opening up a lot of doors, I feel, of what can be possible then as well in the future. I think, again, we're just kind of scratching the surface of that right now. But it's an exciting time to be in this field.
Yeah, I mean, just to add what Anthony said, which is perfectly valid. I wouldn't put it as second fiddle, more rhythm and lead guitar. I think there's a nice harmony that comes when you're using the two fields, the two forms, edge and cloud together. They're not mutually exclusive. And I think that's the narrative that we really need to change in people's minds. Is it's not do you run it on the edge or the cloud? It's you have both at your fingertips. But by the numbers, you have something like 250 billion microcontrollers now in the world today. Maybe it's a little more than that. I mean, the number is always growing, but you have maybe in the thousands, not B, but K amounts of data centers here. That's a bottleneck. Sending data over LTE, over cellular is expensive. And so when we would see customers try to scale up their AI initiatives, yes, you have the cloud. Yes, you want that longevity. Yes, you want that standardization, that homogeneity, the homeostasis that comes with a cloud environment. But the real innovation comes when you find a way to use both. And so I take, the security example, the image classification example. One thing that we've seen quite effective is having multiple stages of intelligence. It's kind of like you would do the low cost, the quick thinking at the edge. Yeah. If you need more thorough processing, something's entered the room, well, wake up the camera, wake up the device, and then when you need to, offload more heavy, complex analysis to the cloud. So that interplay, if you will, is really where I've personally seen some cool solutions develop.
It's an excellent point, right? I think, what you can now do, going back to your point, Anthony, with AI and embedded together collectively is really exciting, right? I don't think Koenig and Richie ever realized when they built C, right, that, we be where we are right now, 2025 with AI. And I like the rhythm and lead guitar? Yeah. I mean, you've definitely said that before, right? that is quite a nice analogy. So moving on then, do you say 250 billion microcontrollers, you said?
Something like that,
okay.
Yeah. That's maybe older statistic.
So one of the things I had here was, are we actually using what we're building? Right. So we've got 250 billion microcontrollers. We have some incredible technology going on. We're sat here in the smart home lab at NXP's offices in Austin. Are consumers using it? And, and are we getting, the bang for our buck out of what we're creating?
It's a great question. I mean, take the mobile phone. So, I mean, you have all these features at your fingertips. You have so much computing capacity at your fingertips. Do you need to max out that device, every day? Probably not. But when you need it, when you want to, I don't know, generate an image or create a new background or edit some photos, sure, that's possible. I think in that 250 billion figure, the average vehicle nowadays might have a few dozen microcontrollers. The average home, between all the appliances and then the smart home energy. So I think from that perspective, it becomes really valuable when you don't know you're using it. When it's ambient intelligence. I think that's what's quite cool. Optimizing the airflow, optimizing the energy consumption. You don't need to explicitly demand, hey, use AI device. I think that's where the real value comes from, not flipping on an AI switch, but the AI switch is there when you need it, whether you know it or not. And I think that's where, again, the edge offers a lot of value because you're not compromising security, you're not compromising integrity of the application, of data privacy. You're doing it in a way that's valuable and secure.
Yeah, I think the idea is a lot of times the AI would be kind of invisible to the end customer. It would just make that product feel better and more intuitive, efficient or intuitive. Like with the doorbell camera, it's not that it would still detect something, but it would be kind of invisible of that. You would see less false positives, you would have better accuracy, and the user doesn't really care how or why that occurs, but AI is helping power that kind of thing, or using less energy in your appliances, or instead of getting a weird diagnostic code in your appliance or in your car, now it's more exact because you have AI that's analyzing the time series data that's coming, and so now it can make the repair of that more efficient because now you know exactly what went wrong and what the problem is, rather than, well, it makes a funny noise and I don't know what that means.
Yeah, I think that's one of the kind of beauties of the maturity of technology in the sense that it becomes seamless, and the user doesn't, as you say, it doesn't really care what chip it is or what AI, what sensor, etc. They just care it works. We're filming today, obviously, this Edge of Tomorrow debate as part of the IoT podcast, and I've often wondered if I shot myself in the foot calling it an IoT podcast. It's almost like calling it an internet podcast, right? 20 years ago, you just
obviously it's
it just is what it is, right? It's just connected, and that's just what happens. So I think that adoption, however we might perceive it looks, and what actually is the end point, is natural progression and selection, right? And I agree with what you're saying, and I think it's a really, really good point. So one of the things that has plagued's maybe too strong a word, but has maybe disrupted some of the growth in both IoT and smart home adoption, as we all know, is standardization, right? So, I think when Matter was announced, it went some way to try and level the playing field of how we connected, the protocols that we were using, etc. What are your thoughts on standardization and convergence, and are we getting it right?
Everyone wins when we can agree and converge on a proper standard. When standards are incorrect, maybe that's a sinking tide, but when we can find one that works, and that takes time. And it's more serendipitous, I think, than top-down thinking. You have to kind of happen upon it, and then you use what matters. I mean, I'll bring it to the AI perspective a little bit. I think one thing that is missing that wouldn't be a plague at all is standardization of these models, of how we develop them, of the operations, of the, not to get too technical, but the layer types, the kernels, the operators. If we could all, right now the locus of power is so centralized in a handful of a few entities, and I think that's true of maybe any industry as it starts to flesh out. Yeah, I can't exactly speak to the connectivity protocols. Maybe Anthony can speak more on that. But in the AI model space, I think we would find tremendous benefit from standardization.
Yeah, I would agree with that. Being able to just take any model and know it's going to be in this format. I mean, PyTorch has kind of accelerated that a little bit.
Yeah.
It's become much more popular since I first started working in it. Yeah,
It's all TensorFlow a few years ago.
Yeah, of course.
And so it's kind of moving in that direction, but I mean, AI is just a very fast moving field. That's one of the big challenges, I think, in general. It's just that there's constantly new breakthroughs, new inventions, new ways of doing things. Because there's so much research being put into it, it's a very new field. And so, trying to optimize those for that and be able to, run the latest and greatest can be challenging, and the lack of standardization does make that more difficult. But then I think that's also just kind of where we are with it right now too, because it is still a very new field.
Yeah, I think one of the things that you just said there is the difficulty within standardization is a race in the development. And if you're constantly developing and it's moving at rocket speed, like nothing I've ever seen.
Oh yeah.
How can you standardize that, right? Because it's just changing every day, right?
Yeah.
So it's almost, you're playing catch up constantly with this. And I guess that's also one of the maybe benefits, but also the challenges as well, right?
Oh, absolutely.
You need room for error. You need the ability to take risks when you don't know, the ground truth of what's the best way to design a ChatGPT, what's the best way to do an LM. No one knows that. If they did, it'd be self-evident.
Yeah.
So I think as we start to mature as an industry, and when you think about the edge semiconductors, I think we'll see tremendous benefit from this risk taking. And when that standardization starts to mature and starts to become applicable, it'll be self-evident.
Well, what's your views on kind of a wish list for Edge AI, right? You're both heavily involved within Edge AI. Where would you like it to go, and what types of things would you like it to be able to achieve in the near future?
Oh man, the wish list is probably too long for this.
All right, maybe the top two. Maybe the top two.
All right, I've got one that comes top to mind. So I mean, intelligence is not, as we know biologically, is not something that happens, one off, and then you're stuck with this static, learned algorithm. It's continuous. And I think one of the trends we saw at the Edge AI Foundation or the Edge AI Summits was this topic of continuous learning, but purely theoretical. It was, okay, we know the brain does this, why don't the chips do this? And I think be a tremendous wish list or tremendous, boom for edge intelligence would be continuous learning. On-device learning is another way to put it. That would just be incredible, so that it's not, hey, here's these labeled images of cat, dog, person, stick it in a doorbell camera and hope that applies. Everything is nuanced. I think a good phrase is, I only want that camera, this phone, to know what my face looks like when it needs to, not every device out there. But I don't know, we're aging, we're changing, we have different, looks on different days. That continuous learning, it's going to change everything once it happens.
I would agree with that. I think also a lot of some of the struggle is just being able to create these niche models, especially for the embedded side. A lot of times, you find these models online or research papers. It's kind of generic, and that works well as a proof of concept. That is fine for showing that my model can recognize 1,000 different categories really well. But an embedded application, especially, you're usually not trying to identify 1,000 different categories. You're trying to identify one or two specific things, and so it's not even just the model structure. It's just getting that data, getting it trained very well, and then using that to be able to shrink that model. Because we talked about like LLMs, kind of if you specialize, you can shrink that down. Well, the same kind of thing would happen for almost any sort of model, or if you can specialize, then it should allow you to shrink that model to be able to fit now, instead of a higher end application processor, put it in a microcontroller, save your BOM cost, save energy, and now it's battery powered. Now it kind of opens up new opportunities, but not trivial, especially if you don't have that AI expertise, which a lot of embedded developers don't have yet. And that's just education is, I think, also just something that is really important, because I always say, like, the Venn diagram of AI ML experts and people that know embedded really well, there's not a ton of crossover yet.
So the wish is more kind of overlap.
Yeah,
Those two. Yeah, that makes sense.
And getting that, more overlap with that.
I guess that's the inflection point, isn't it? With a large language model, albeit a large language model is also a subjective term. When does it become a large language model compared to a small language model? But getting that to run on a microcontroller with the compute power, with a coalition of other technologies that we're seeing at the moment, like energy harvesting, etc., for continuous running and maintenance for objects, devices that may be running in the field where you might not be able to touch them and see them. This for me is really important, right? And I think it's the next step, isn't it, right? Certainly getting that ability to run it on such a smaller base device, I think will really take Edge AI really forward.
Yeah.
It's very interesting when I talk to customers, especially like at trade shows where you're kind of getting everybody and anybody is what their idea of a small model is.
Yeah.
They're wild.
Yeah.
So it's like, oh, it's less than 2 gigabytes, so I could like run it on the edge.
Yeah.
Versus like I have a microcontroller with 512K flash.
Yeah.
What edge are you talking about?
Yeah. How close to the edge, right?
Yeah.
But it's almost like resource constrained, right? Is anything ever resource constrained anymore? It's almost like an existentialist term, isn't it? Because, resource constrained 15 years ago compared to today is wildly different, isn't it?
Well, I think that's the kind of the nail on the head. We have this capacity to consume capacity. When you think about 20 years ago with the internet, okay, you might have waited a bit of time. I mean, this is a little bit, predating myself, but nowadays the amount of information that's loaded into a web page, the amount of stuff that's shoved in there, because you have the bandwidth to do so, you have the service to do so. One thing I will say, it's a bit counterintuitive, is I'm waiting for this, I'm really actually quite eager for it, is when we stop depending on the cloud to trickle down AI models, large, small, doesn't matter. I really want to find out when the edge is creating models. When will these algorithms be born at the edge, and then maybe they scale up, maybe they don't. But I think we have to, find an inflection point, if you will, where we're not waiting for cloud models to get compressed and squeezed, which is definitely a powerful force and definitely happens. But I'm thinking about the era where models are just born at the edge. They're created there, they're trained there, they're developed there.
Yeah. No, it's really interesting. I mean, it's it's quite a fascinating field. So it wouldn't be right if I didn't ask about NXP's perspective, right? Directly on Edge AI. So NXP has a tremendous reputation. Very, very good company to work for, 18 years, right? That says it all.
True.
How does NXP approach Edge AI across different product categories in terms of scaling hardware, software complexity, different application needs, and what is the biggest growth market or markets, should I say, that NXP currently seeing within Edge AI?
Can we talk about that? I mean,
within reason, no secret sauce, no secret sauce.
I'll tell you what brought me to the fray, and I mean, Anthony's been here for some time, but why I was quite excited to join and why I was eager is I think that when you come from a background of security, a long pedigree and legacy of providing, it's the name says it all. We're in the secure connected edge. So I think when you add security and connectivity plus intelligence, that's a very powerful offering. So I think that's what got me kind of on board to join. Lots of people can do algorithms, lots of people can do connectivity, but doing it all is actually quite a challenge. And adding new features without compromising that security is another challenge, right? You want to have the upside of innovation, but you don't want to compromise that reputation, that security. So I would think The North Star that we sometimes look to, I know this isn't exactly your question, but market specific, is performance and ease of use. When we want to provide something to a customer in medical, in industrial, we want to be able to make it the best, most performant and the easiest to use. And I think that's where we can actually really deliver powerful solutions. So growth market, I mean, we've talked on a few. IoT is too broad of a phrase, but I think I would call it human machine interfaces. HMI is really something that is going to be just changed by, we haven't talked about agent frameworks, AI agent frameworks, but I mean, when you can add that to a device without, again, compromising that security, it's going to change. We can't even speculate on it because it's just too dramatic of a change to even think about.
Davis, yeah, great. I mean, in terms of agnostic view on making sure that ease of use and performance across all markets. I mean, that's got to be number one, right? And I can see why NXP is taking that approach. Anthony, is there anything that you want to add to that?
I mean, from the technical side, that's part of the reason that we developed our own neural processing unit, right, integrating into our chips. So we wanted something that we could scale from the very low-end microcontrollers to our highest-end application processors that are running Linux, but still keep that same efficiency, keep the same enablement around it, the same kind of process. I, as a systems engineer, I'm the one helping the customers actually do all this. So it helps make my job a lot easier whenever this all works really well and seamlessly, and out of the box. And so I think we've done a really great job of being able to use our NPU without having basically everything's handled with our libraries. So there's user application code that you have to do to take advantage of that power that we have, and then being able to just have like an NPU and a small microcontroller to accelerate this kind of use cases, especially like time series and audio. I think a lot of especially the larger models are focused all on vision. That's kind of the hot one, but in the embedded world, it's really time series, especially a microcontroller, because they're small enough to fit in those fast enough. In a lot of cases, you don't necessarily need the NPU for those, but in those more complex ones, then it can definitely pay a lot of dividends and save you a lot of power, because you can wake up, do your inferencing, and then go back to sleep and save a ton of power that way.
Yeah, I'd be reluctant not to mention 3 letters, but a lot of implications. EIQ. So EIQ is the brand behind our software and our hardware. And Anthony rightfully mentioned that the neural processing unit. A few years ago it'd be almost unthinkable. Why would you need this neural processing unit on these type of devices? But we were actually, I think, ahead of the curve and a bit prescient in thinking, okay, well, maybe you don't need it now, going back a few years, but you're going to, because these models are coming, because these new features are coming, and so you future-proof yourself a little bit. And I also like the thinking behind how do we do ourselves a service, and then that service is going to help the end customers. If we can make our own lives easier, then it's going to also help other people down the road.
Thank you so much. That's a really interesting view, and I appreciate you sharing it. So coming to the end of the show today, I've got some quick fire hot take questions, right? So
all right, let's go.
So the secret is with this: try and be as succinct as possible. Okay. One overrated and one underrated trend in edge AI, and you can take either one, guys.
Underrated is the time series. I think the vision stuff, image classification gets a lot of the spotlight because it's visual, a demo as well. But time series data, unsexy data that comes from machines, accelerometers, inertial sensors, all that kind of stuff, that's everywhere. Yeah, that's underrated.
All right, so it means you've got overrated.
Sorry.
I think the obsession on tops of it, just because I don't think it's a great metric. Like it can tell you some information. If you have a processor that's 2x tops of another one, your model is almost never going to actually run twice as fast. Maybe 1.5 at best, and sometimes even less, because these models aren't able to take advantage of the full bandwidth. I always like using the analogy that it's like putting a really high-end engine in a car. That will help. That might mean it could go faster, but there's a lot of other aspects of that car, of the handling and the driver, that are going to make a huge difference as well. And so I think just blindly comparing tops numbers, especially against different architectures, different chips, can be very misleading at times.
So succinctly, underrated time series data, overrated tops.
Got it. And maybe this kind of leads into my next quickfire question, right, around time series, but the next big unlock for edge AI. So the next big thing that's going to progress edge AI a step ahead of where it is today.
Agents, AI agents that are behind the scenes, under the hood, that orchestrates communication, data gathering. A lot of the stuff that you have to cognizantly pay attention to now that you don't want to or don't need to as an engineer, as a developer. I think that's going to really free up a lot of hands and minds to do bigger, better things.
Awesome. Anthony?
I think riffing off of what Davis said, just having models designed for the edge.
Yeah. And for all it's worth, I agree, right? I think at the moment, the models aren't necessarily perfectly designed for that, and it's all about how you're taking what is, we spoke about it earlier, a large language model and what is subjectively a smaller language model and something that is specifically to the edge, which is fit for purpose, right? So I'd agree. Last quick fire question. Where's Edge AI heading in the next 5 to 10 years? And I'm going to come back in 5 to 10 years and ask you if that's right.
Fact check us. You want to go first?
Oh, I mean, I think it's just going to become more and more ubiquitous. I think we're building the tools, the enablement, the ecosystem around it. And so I think it's going to, like it's was saying, it's going to be just make our everyday products better, and not necessarily in a flashy way, but just in a way where it just makes things easier for the end customers and end users.
I would say domain-specific intelligence. Right now, we're taking these general-purpose models, we're taking these models that are trained on the whole internet. But when you're in medical, when you're in your smart home, when you're in a vehicle, you don't need all that, excess at the edge. So I think domain-specialized, domain-specific intelligence is really where we'll be in 5-10 years, and you'll see that.
Yeah, I'll hold you to it. No, but I mean, it's very logical. I mean, we started the podcast today talking about 10 years around smart kettles and smart fridges, right? And actually, did we need them? Did we use them? Was it fit for purpose? But we could only go on the data and the facts that we had at that point. Mm-hmm. And right now, domain-specific models, as you say, and, Anthony, your comments, it's logical. It would be illogical not to suggest it, right? Yeah. But it would be interesting to see if there's some sort of segue or something coming along that is going to change our perception on that. But it'll be interesting to see. And the final point, guys. So we often like to ask guests what they would like to see the next person talk about on the Edge of Tomorrow show. What would that be for you? What would you like to see the next debate to be on?
We are both a supplier and a consumer of intelligence. I would like to really hear the end user perspective, someone that's actually creating these devices. We have a strong focus at NXP on specific. I would like to hear, the voice of the end user. I'd really like to hear what people think of all the stuff we're saying, and kind of fact check these promises, fact check these value adds, and say, hey, we think it's great because we're making it. Do you also think so? And I think that'd be awesome to know.
Yeah. Guys, listen, I've really enjoyed talking to you today. Honestly, it's been a really interesting debate. I think you're both clearly very passionate and knowledgeable about the space, and what a wonderful location to do it in today. So thank you so much for your time. Where can people find out more about you, about NXP, LinkedIn, I assume, different areas about you guys individually as well?
I would say NXP.com is a great resource. I'd also say check out our EIQ page. So I mentioned that earlier about the software and hardware. That's more than a brand. It's a solution set that people should definitely learn more about. So EIQ at NXP.com.
Excellent. Anthony, Davis, thank you so much.
Thanks, Tom.
Thank you.
Thank you.
Now, here are some of the demos in the Smart Home Lab.
This is a driver monitoring system. So you put this in a car to detect drowsy or distracted driving. So if I'm looking, the camera would be facing my face. And so if I look away, then it'll detect that I'm being distracted. If I'm yawning, then I'll detect that maybe I'm getting drowsy or closing my eyes. Or on my phone, then it can alert the user, maybe make an audible beep, that kind of thing. Hey, NXP, how do I enable the fog lights?
You can enable the fog lights by setting the exterior lamp control on fog mode, which is located on the instrument panel to the left of the steering wheel.
What is the fuel capacity?
For standard cutaway models, the fuel tank capacity is 1 L32, 0 gal.
When is my next maintenance?
The next maintenance for your GM car is scheduled for 100,000 miles.
So taking out the can of soup, take out the can of soup. This is using my face to unlock the door automatically using the face recognition.
Lock has been opened. Please close the door.
Hey, conference room, lights on. Hey, conference room, Lights off. This is a smart home security that's using AI ML to detect suspicious packets that are coming over the network. And so that way it can detect when that's happening and be able to block off access to the network automatically using the AI ML model that's running on the device. This is, so it's simulating so there's a ping flood attack. And so then it's blocking this MAC address from accessing the network once it detects that kind of attack.